welcome to the first edition of our Neurons and Peppers meetup. We're very glad to see you all here today. We're very glad also to see all the hype that there was about the event. We had a lot of registrations. Fortunately, we could not accept everyone, but the next time we'll make sure to get an even bigger venue to host most of the people. So first to introduce, hopefully this works. Technical pros for the first edition. I don't need the slide actually. I just wanted to explain you a little bit the concept of the meetup. And I thought that a good explanation could be with the name. So of course we came up with this name Neurons. You guess why? Because all of the neural networks and the deep learning aspects, because it's an AI meetup. And also because you'll need to mobilize most of your neurons if you don't want to end up like this. Because we chose to make this meetup very tech. So for tech people, from the tech people. So don't worry, it will be, if you focus, everything will be easy, but just wanting to make that clear. And also we choose peppers because usually, even if this one is green, peppers are hot. And the only thing we'll be talking here today is hot topics in AI, state-of-the-art topics. And you'll see later, you'll have some green peppers and you can eat. It's not because they're green that they're not hot. And also we like the play on words with papers because we'll be talking a lot, so state of the art in paper publications. So that was for us a good name. And now you understand how it represents this meetup. So I talked about state of the art topics. The other very important part of this meetup is talented speakers. Rafael and I, we've been to a lot of meetups over the years, and usually we're pretty frustrated when a speaker is not clearly good enough to explain in clear terms all the key concepts that he wants to give the audience. And usually it's very frustrating for the speaker because he sees that the audience is lost, and also for the audience because they just don't understand anything. So we make sure to select great speakers, people that know how to vulgarize and how to explain concepts, hard concepts in very simple terms, to make sure that all of these presentations are easy to understand and easy to focus on. Just a quick word on Datacraft. So we're the company, me and Rafael and other people here, we work at Datacraft. You have some numbers here. Basically, we're an AI club. We organize events that allow people from the tech community and the AI ecosystem to just share knowledge and work together. Basically, we organize 2 events per week. We have sometimes feedback from a team that has implemented the solution, but sometimes also technical workshops and practical workshops where you'll be solving a problem, an AI problem with other data scientists that come from a different industry. So usually there's a lot of sharing, a lot of knowledge sharing and collaboration during these events. And it allows people just to accelerate their project by maybe not repeating some mistakes that have been made or discovering new libraries. For instance, these are very quickly some events that we have coming up very soon. We have a paper reading group. There's a small group of people getting in the room, talking about a paper and just talking about AI in general. That's how the last edition ended up, and it was very nice. A practical workshop with in an afternoon when you'll discover the mapping library, which is to measure your model's uncertainty. And this workshop is organized with the creator of the library. And also in June, GenAI for Dev. This is a study that has been made by two people. They've helped big companies implement GenAI tools for dev, so Cursor, Data Copilot, all those tools that you know. And they came up with some feedback and also how is the best way to implement these kind of tools in the development teams. And finally, the biggest event that we organize is the Datacraft Award ceremony. It takes place in Salvagram in June, and it's more than 500 people in a beautiful venue to award the best AI projects that we've seen. We've received more than 80 registrations this year, so it was a lot of work that we just ended up today. But you can still register online and attend the event for that night. Just a special thanks to the Village Baïséa for hosting us, for trusting us for this first edition. For the next editions, we're looking also for venues that will welcome us. We're always happy to see our members and all our partners in their own place. And I'll leave you just say a few words to introduce the village. Thank you.
Thank you, guys. Hi, I'm Axel Baudry, and I'm with Emmanuel over there. We are in Le Village Baïséa. So we are very glad to actually welcome you today. What is Le Village Baissa? Le Village Baissa is an accelerator of startups. So that's why we like to actually partner with Datacrat, because here at Le Village Baissa we have a lot of AI startups, and we very much like this type of topics. So what do we do here? We help startups to actually reduce the risk of their business, of their projects. But it's not only what we are doing. We are actually trying to help big corporations and actually members of DataCrat as well to actually adapt practices of startups. We call that hybridization in between startups and big corporation. And so we have one part of us that is actually helping the startups grow, but another part of us, which is the corporate lab, that is actually a consulting branch that is actually helping big corporations innovate. We help them throughout the innovation process from the strategy to actually the hybridization with the startups. And that's why we actually help the startups with these types of events, learning from you guys, actually networking, and yeah, I actually having a good time with everyone. So very welcome. Thank you, Excel. So next is just a few words on the concept of the meetup. So I'm Raphael. I will be your host for tonight, and I will be working with the speakers today to give you an interactive experience. So we've introduced a concept with Neurons and Peppers, which is the following. In front of every seat you are seated in, you should be able to see that QR code. Hopefully you also have the Wi-Fi password that you scanned earlier. And so this chat that you will access allows you to ask questions live, which will which will help me in the end. Sorry, ask your questions directly to the speakers, and I will be allowed to interrupt them during their speech. Uh, Also, some of your questions will be asked at the end of the talks, and they will be carefully selected by Mark, which is now in the backstage. So if that sounds about right, let me give you a clear picture of the lineup we have tonight. So the first one to come up with a speech will be Pierre from Meta. We've known Pierre for quite some time now at Datacraft. He was also there at some of our workshops he delivered, where he showed us how to do watermarking in practice. And so today, Pierre is there to present his latest work that he did on Watermark Anything model. So you might know the segment anything model, and it has some links to it. So Pierre will tell you a bit more about that. After that, we have Tony and Antonio from Evelyn Technologies. So you might know them because they released a very hot paper a few months ago, I would say, that is called Colpali. I think that Colpali is now powering most of enterprise RAG applications because of its simplicity and effectiveness. So initially, I asked Manuel Face, who is I think the main author of this paper, to come by, but unfortunately he had something to deal with, a paper at ICLR that he's now presenting at Singapore, and so he gave me two of his best co-authors to present the paper today. So I'm glad to have them too. And sorry, finally, we'll have Yaya, which is a PhD student at Loria. And Yaya is working on all kinds of methods that we can use to compress the size of LLMs without compromising their performance. So he will give you an overview of the techniques we have in practice today and which one works and which one don't work. So without further ado, I will introduce Pierre, who will give his first talk about Watermark Anything. Pierre, you have the slider and the mic.
All right, so thanks a lot. I have the huge honor to be the first speaker of the first Neuron paper. So thanks a lot, Raphael. I hope to be like to deliver. And so today I will talk about watermarking. Okay. So who in this room has already heard about watermarking? You raise your hands. So that's maybe 99%. I think if I had asked the question maybe 1 year ago, or 2 years ago, I would have maybe 1 or 2 hands in the room, maybe a bit more here, but that was the scope of watermarking, and now everybody's talking about it. So that's the reason why I'm here today, because it's hot. And so the task of watermarking is the following. You have an image or like another input. In this case, we talk mostly about images. You will try to put something inside it, and you should be able to retrieve the mark that you put inside it, even if the image is transformed when being transmitted from user to user. And so it has several applications. The most famous ones are the first one, which is copy detection, which is used for moderation and IP protection. So the idea is to put a mark in an image to help us to trace it and to ensure that we can say, oh, this is a copy of this one. And the other application, which is the one that everybody is talking about now, is to trace AI-generated content. So it can be used in all modalities and in images in particular. So you can have a watermark that is added on top of the image generation process, such that you are able to say, oh, this is a watermark image, this is an AI-generated image, and it has been generated by this model or this one. And so this is being put in practice by all of the AI companies now. So Meta, Google, I think for everything that is image generation, everybody has a watermark. And so this is the stuff that I would be mostly talking about today. So I would be talking about a paper called Watermark Anything with Localized Messages, which is a paper that we published at ACLR, but I'm not going to Singapore. So I'm here, which is way better. Yeah. And so the current methods, the way they work today, is the following. So you have two neural networks, one embedder and one extractor. What you will use the embedder for is you take the image, you take a binary message, and you get a watermarked image, which would be very close to the first image. Then you apply some augmentations to the image, like the robustness, like brightness changes, contrasts, JTAG compression, crops, whatever you want. And then you have another network called the extractor that will have to extract the binary message that you put as input. And usually you train everything end to end, and you end up with something that is great. And that's, for instance, what is used in the image generation model at Meta. But it has some limitations. First, now people are using generative models also to edit images. So let's say I have an image of a horse and I want to change it to a zebra. Then I have my watermark only on the zebra side of the image. And now my question is it watermarked? And I have two answers to it. Like, no, because most of the image is not watermarked. And yes, because half of the image is watermarked. So we don't really know what to answer. And even if we say, oh, okay, I want this part to be watermarked, the actual area that is watermarked in the image will be quite small. So the results would be wrong most of the day. So this is something that we cannot handle for now. There is another thing that we cannot handle, which is the fact that, let's say I have an image generation model from Meta, and I have another one from Google, and they use different messages. Now I have two little ducks that I want to put on my image. And I end up with an image with two different messages, two different watermarks. What am I supposed to think here? Should I answer just one message? One of both, like both of them? Like maybe three, And so these are the questions that we try to answer in Watermark Anything, also called WAM. And the way we rethink the problem is to think it as a segmentation task, which is also why we give it this name. And now we want the extraction to give not only an overall message, but also a detection map that we say for every pixel of the image if the pixel is watermarked or not. And for every pixel that is watermarked, we want to associate it a message, like a binary message that would say this is message 1 or message 2. And so if you ask about the name, this is the origin. We did watermarking. We had this segmentation model that was trendy at this time called Segment Anything. And so we just fusion both and get Watermark Anything. And now I will talk about how we actually develop the model how we came up with like the ideas and how we trained it. And the process you will see is quite similar to what I presented before, but there are two very different parts. So the first part is quite similar to what I presented before. So we have an embedder that will take a binary message, the original image, and that will produce a noise. We will add this noise to the original image and get the watermarked image. Now the second part is quite different than before. So before we only had some augmentations that were JPEG, Regness, and these kind of augmentations. Now we have something else, which is that we will apply a mask to the watermark area. So the way we sample this mask is either randomly, so that by drawing some shapes in the image, or by using segmentation masks from the dataset, from, for instance, in Coco or segmented in film datasets. And we use this mask to drop the watermark in the black areas. And then we apply some augmentations that we want to be reversed against, for instance, JPEG, resize, crops, and so. So we end up with an augmented watermark image, but also with the detection hidden up. And the extractor now will be a bit different also than before. Before we were only predicting a binary message. Now we predict both a detection map and one binary message per pixel. So here, like this dimension would be the message. And to train this, we have two losses. The first one is the detection loss. So we try to make sure that this output is similar to the mask that we used in the augmentation. This is the first loss. And the second loss is we will take all the white pixels, so the ones that have the watermark, and we'll make sure that these pixels have this message. And so for this loss, we use the binary cross entropy for those who know what it is. And so that's as easy as this. But there is something that we haven't done yet, which is that if you just apply the watermark as it is now, the watermarked image that you would get, I don't know if you can see here, but it's pretty bad. Like you can see a lot of noise, some stripes, and something that will make the image quite bad. So we use what is called a JND heatmap. So JND is for just noticeable difference, and that's something that was developed in the 90s and 2000s. And the idea is just to have an image and say for every pixel of the image where I would see the distortion. So for instance, if I take a picture of this room, I can say if I apply some noise in the background, it will be very easy to see it. And so here, for instance, in the sky. But if I add it on the edges of the image and on textured areas, it will be pretty hard. And so what we do is just that we rescale the distortion by this heat map that will give us something like this. So here we can see that the distortion is applied mostly on the edges. And so in practice, you cannot easily see it. So if you just apply it at inference time, you will lose a bit of performance. But in practice, you can just fine tune with it and you will retrieve almost the same performance as you would have gotten before. So this is for imperceptibility. Now, there is something else that we haven't done yet, which is multiple messages. So at the moment, we had one message that was randomly sampled, but we didn't have different messages in the same image. So if you ask the extractor to predict one message per pixel, it would actually give an average message for all pixels, which is not something that we want. But in practice, again, fine-tuning on different messages is enough to retrieve the same performance as if you had trained from scratch with different messages. And in practice, what we do is that we sample, so we have a batch of images. We pass the same image several times to the embedder, so we get like K distortions for different messages. And we'll watermark independently some objects of the image that are sampled with the segmentation masks of Coco. And then we will paste these objects with different messages inside new images and try to predict here the message, a different message for every pixel. So the only thing that changes really is the loss, where here the different pixels may have different messages. But other than that, it's exactly the same as before. So I talked before about fine-tuning, but in practice, it's more of a post-training. So I think in the LLM community, post-training is a familiar term. it's just the fact that because the fine-tuning is almost as long as the pre-training, we say that it's a post-training. So here, for instance, the pre-training is 2.5 days on 8 GPUs, and adding perceptual constraints and the multiple messages is 1.5 days on 8 GPUs. All right. So now that we have trained our models, we want to use them in practice. And the way we'll do it is by taking the image, using it to get the extraction. We have the detection map that we say this is a watermarked object and this is a watermarked object. And then we would have one message for every pixel. So here, for instance, is the pixel for, so it's the message for pixel ij. And I will select all the white pixels and get n vectors. So n messages, basically, one for every pixels. And the way we retrieve the different clusters is by using an algorithm called dbscan, which is very nice because it doesn't need to have in advance the number of clusters. So we get the n messages, we cluster them with dbscan, we get two groups, and we get an assignment saying this pixel belongs to group 1 and has this message, and this pixel belongs to group 2 and has the other message. And so we end up with something like this, which is the first figure of the paper. So this is the training. And now I will talk about the boring part, which is evaluation, but I will try to go fast because it's not that interesting. So there are two very important criteria. The first one is imperceptibility. So we want the distortion introduced to the image to be imperceptible. And the other one is robustness, meaning that we want to have performance of detection and localization and so on for different image modulations. So for imperceptibility, the images that you would get would look something like this. So from far away, it's not very good, but I have a zoomed image, which is better. But the contrast of the display is not very good. So, what I want to say here is that in textured areas, actually a lot of watermarks pass it through, and actually you can see here in the fur of the bear, you can like feel the watermark, and this is something that we will improve in the future models. Imperceptibility. So quantitatively also, we can compare them with other models, and we are on par, but we could do better. Now for the robustness, compared to before. So before we were only interested in having one message in, one message out, and the way we would compute the performance would be to compute what is called the bit accuracy, which is you compare the number of bits that match or not in the two messages. And here in WAM we have new stuff to evaluate on. The first one is detection, meaning that we want to know if an image is watermarked or not. And so the way we do it is just by computing how many pixels in an image is watermarked. And the localization, which is the fact that you are able to retrieve exactly where the image is watermarked. And so this is done with MIUU for those who do it. And what we are really interested in here is the robustness to in-painting and splicing. So splicing is about putting objects in new images. And in all of these, we are better than all the other methods. Same for localization. So the only method that existed before that did it was called edit garb. And in practice, if you crop the image, it's completely removed. And in our case, it's not the case. So we are the red garb. But what's nicer is that we have like visual examples of the detection. And so, for instance, here we have the watermark image, and we try to edit some parts of the image. Like for instance, here we in-painted some birds and try to remove them. And the extractor would say, oh, this is the watermark part. The user removed the watermark area here and here. And the bit accuracy on this would be perfect. And so this is a demo in the GitHub. I will show it later. And you can actually do the figure 1 of the paper yourself. But what I want to show, I don't know if I have the time. I have the time, yes. So there is a guy on Hugging Face who did a demo, and I found it nice, so I will share it with you. Okay. So I will redo the demo just to show you that's not fake. This one is. So this is image 1. And so the demo allows you to select some masks in the image. So here I will say bounding, and then, so it's not very well done, but it's good enough. So I click here and I click here and it will create a mask. So this is the red mask. And then I will create, let's say, a blue mask, which will be the right part of the image. I will embed the watermark. So this is the watermark image. I will download it. And so this is the position of the watermark that I put before. And then I will try to detect. So currently the demo does not work for multiple messages, but I can just, it was the free, right? Right, this one. There's this one. I hope it will work. Okay, so here I have the two clusters of watermark. So I cannot distinguish which one is which because the demo does not work well. But in practice, if you want to do it, you can do it. So here, for instance, it's split into multiples. But I don't know why sometimes it does make a timeout. Maybe you can try it. Yeah, I think it will time out. Sorry about this. You can try it yourself in the GitHub. I did not want to. We start again the zebra now. I didn't want to to end the talk here without talking about this. So so we put the paper on archive, and it was taken in Hacker News. You had some people talking about it, and a huge portion of the people that were talking about the papers were talking about like this part of the paper, which was environmental impact. And so we, compared to many papers that just put the cost of training their models, we put the cost of all of our experiments. So from start to finish of the paper. So we started the paper approximately in April of last year, and we ended it in October. So it's approximately 6 months, and we have two main authors in the paper, so Tom and myself. And so this represents approximately 20 tons of CO2 equivalents if you get just the GPU hours. So only the electrical consumption of the GPUs, which is approximately, if I'm not mistaken, maybe let's say 1 ton for one flight from New York to Paris. And maybe if you will do it from Paris to Singapore, it will be half. So only took it twice. So it would be like 10 people going to ICLR conference. So yeah, I don't really know what to do about it, but I think it's useful to share this kind of information. So the main takeaways of this talk are that first, image watermarking is getting very important. It's asked by regulators more and more. And so this kind of research is also very important because it can show that the limitations that we thought before can actually be broken. And so, for instance, here, the fact that previous methods could not handle different messages, painting, splicing, and now we are able to do it, I think it's very nice. And so the way we do it is by rethinking image watermarking as a segmentation task, which greatly improved the results against these kind of augmentations. So thanks a lot for attending this talk. If you are interested in the paper, you can scan the QR code and read it, or just like print it and look at it later. Thanks a lot.